Configuration. In this nugget, we're going to talk about configuring your Linux system. First, we'll talk about the configuration options that are available to you in your BIOS, and then we'll move on and talk about the also informative yet mysterious proc directory. You can learn a lot from looking around in the proc directory, and I'll give you a big picture overview of what it's used for, and talk about the uses of a few important files in there in particular. And finally, we'll go over how to configure a sound card and a modem for your Linux system. Let's get to work. The first thing that I want to do is just show you a BIOS setup screen. And you get into this screen before your system actually boots up. On my system, just prior to when it's going to boot up, it says press F2 to enter setup, and this is how I get into the BIOS screen, by pressing F2 there. F2 is, I think, the most common key to press to get into the BIOS setup screen, but it could vary between processors or between chips. And so just look for the message on your computer before your system actually boots up, and then you'll get into this BIOS setup screen. Now, a lot of the BIOS settings Linux actually ignores, but there are some that it pays attention to and that are important. Things like system time and system date are both set in the BIOS. These are what is known as like the hardware clock, and this is where the Linux system gets its time from, and that's from the BIOS time settings. So in the BIOS utility, I can move my arrow left and right to move amongst these menu options up at the top, and I can move my arrow up and down to change these options here. Okay, so if I move my arrow to the right, I can go to advanced features. If I move my arrow down a few, I can go to I/O device configuration. I can hit enter there, and I can set various properties of my serial ports, my parallel ports, my floppy disk controllers, things like that. And you can page through here and like hit enter, and over, at least on my BIOS over here, it gives you an idea of what each of the different settings does for each of the options. So I can hit escape and get back out. One of the main menu options up here is the boot option, and this is actually a very important option setting in the BIOS. This determines the order that your hardware looks at, which devices are looked at first to boot up. So the first thing that's looked at are floppy disks, the removable devices, then a CD-ROM, and then the hard drive. Okay, so I think it's good to have it in this order so that if anything ever does happen to your hard drive and it's not bootable, then what you can do is you can just stick in a rescue floppy disk or stick in a CD that's bootable, some distribution CD that's bootable, and you can put those in, and that will sort of get you around the problem with your hard drive not booting up, and then you can work through it with fdisk or something like that and look at what you need to change to make your disk bootable again. Okay, so that's actually a very important setting, and that is one setting that Linux does pay attention to. The next main menu option here is exit. If you were just messing around and you didn't know what you were doing, make sure you exit with discarding the changes. But if you've made changes that you actually want to preserve, then you can just hit exit with saving the changes. So before we start talking about some configuration settings that we can make in Linux, what I want to do first is I just want to give you a little bit of a tour of this directory called the proc directory. All right, and first what we're going to do is just do an ls here, and you can see the kind of stuff that's in here. This directory is not actually a directory on your hard drive. All right, this is what is called a virtual directory or a virtual file system. And what this really is it's sort of a window into the kernel. Okay, it's a window into the heart of the kernel. And there's all sorts of information in this directory that various Linux commands probe these files and directories in here to get information to display to the screen for you. All right, so let's look at it like this. Let's do an ls-l of this directory. So we're going to do a long listing, and you can see here that all the files that are listed here, all these numbered files, all have size 0. Everything has size 0. As you go down, all the name files have size 0, except this one thing called kcore that is gigantic, okay? And then there's this thing called self that links over here to 3076. Okay, it's a symbolic link to 3076, and it takes up very little space. Okay, now let's do another ls-l here and pipe that through more, and let's page down, and you'll see the exact same thing again, but when we get down to self this time, now self is pointing to 3081. Okay, so what's going on here? Well, all of these numbers here all these things are actually processes on your system. And self is a special symbolic link that points to the process that is currently running right now on the CPU. All right, so you understand how your CPU works, right? There's all these processes that you could be, running, quote unquote, running right now, but only one of those processes is actually running at any one time. And the slices of time that a process might run might be like a millisecond or something ridiculously small like that. And then the CPU swaps out and runs some other process for a millisecond, then swaps out and runs some other process, then swaps out and runs some other process. And so all the different processes on your system that are quote unquote running are actually sharing the CPU in these little tiny slices of time. Okay, so whatever process is actually running right that very second that we looked at the self link, that's the process that's actually running. So the very first time when I typed ls minus l, that creates a process. That ls minus l command is actually a process on the system, and the self link here was pointing to the process identification number for that ls minus l command. When I ran ls minus l a second time, then there was a new process created, and the self link pointed to that process. So as soon as all of the text gets displayed to the screen that ls minus l needs to display, then that process is over, and the process identification number goes away. All right, so that's what's happening here. Now, all of these process identification numbers in the proc directory are actually directories. All right, and if we go down, let's just pick one here, like CD 1933. Okay, and let's look at what's in there. Well, what's in there are information about that process. And like I said, these things really aren't, these are not really files or directories. These are, it looks like a file and a directory to ease our understanding of it. So we can look at this and say, okay, I'm in the 1933 directory. Here's information about process 1933. Like, for instance, what was the command that was typed on the command line to make this process execute? And that was user bin gnome session. So the process 1933 has to do with the gnome session manager. Okay, so that's the kind of stuff that is in this directory. There's information in this directory about memory usage, the status of the process, whether it's running or suspended, or whether it's doing I/O or something like that. Okay, and every process in the proc directory has each process is itself a quote unquote directory that has all of this information in it. Okay. Now, when you go to do something on your system, like you type a ps command, like ps minus ax or something, and let's pipe that through more. Well, what ps minus ax is actually doing is it's going up to the proc directory and gathering information about all the processes that are listed in that proc directory, and it looks down into the particular process's subdirectory of proc to see which command it was that is tied to this particular process. This S here has to do with the suspended state because it's not running right now, and so that information is also in the proc directory. So the ps command is actually just making it easy on you. You could go and get all this information without typing ps. You could just go and get all this information by just looking in the proc directory and poking around yourself. All right, well, there's other things in the proc directory besides this process information that we just looked at. There's information about, your processor, for instance. So if you look at CPU info, that'll tell you some of the specs on your processor, like how fast it is, how much cache memory it is, stuff like that. Okay. Other things that are in here are things like mem info. That gives you information about memory on your system. So you can look at how much memory there is in the system, how much is being used, how much is free, how much swap space there is, how much swap space is being free, that sort of thing. You can look at, like if you go into the IDE directory and you go in there, then you can look at the drivers that are in use on your system. So for this system, I've got the IDE CD-ROM driver version 4.59, the floppy driver 0.99, the IDE disk version 1.17, and so on. Okay, so there's all sorts of information in the proc directory, and if you poke around in here, you can gain all sorts of, like I said, you can just learn all sorts of things about your system. Now, don't start start editing stuff in here, okay, that's another topic that we're not going to get to in this nugget. And suffice it to say that if you start editing stuff in this directory, that all hell could break loose. Okay, so be really careful about editing stuff in here. You don't want to do that unless you really know what you're doing. But just realize that there's all sorts of information within here that you don't normally like think about with your system. But if you need to get some specific piece of information, this is where it is. And like we were saying about the PS command, how it goes up and looks for all this process information to display out to your screen. Well, there's other commands as well that use this information. Like the load average here, right? If we look at this, then we're going to see the load average right now for my system. And this is the same kind of thing that comes up like when I type the top command, all right? And I'm looking at the current state of all the processes on the system, how much load there is. This is where the top is getting its load average. All right. If we look at the uptime file, there's this cryptic stuff in here that basically is what it's saying is how long the system has been up. Now we look at this and we say, what the heck is going on here? I can't read that. I don't know how long this system has been up. And that's why there's a command called uptime. And this command that's called uptime just interprets this, okay, and then displays the current information to the screen. Okay, so it's telling us, what time it is and how long the system has been up and what the load average is. And you can see the load average has changed since we catted that file just a minute ago. If we print that out again and then immediately do an uptime command, they'll pretty much match up, or at least match up a little bit more closely. And this is another thing that's constantly changing. Okay, so don't think of it like a file that's being updated, but it's just information that the kernel is keeping track of, and then by looking at this file, we're really just sort of like probing the kernel to get this information out of it. All right, so think of it that way. To update this load average quote unquote file, there's no disk writes or anything like that. Okay, this is a virtual file system that we're talking about. Well, now let's talk about configuring and adding new hardware to your Linux system. As Linux is evolving, it's getting easier and easier to add hardware and have it sort of be automatically configured for your system. A lot of times when you put plug a new board into your motherboard or something like that, then, the kernel or the BIOS takes control and makes a lot of the little settings so that everything works correctly. All right, so a lot of what we're going to talk about right now applies to older hardware. So if you're taking some old box and you're refurbishing it to put Linux on it, or if you're using older ISA cards in some box instead of newer PCI cards, because that's what you have available to you, you might run into problems like what we're going to talk about. So a lot of these problems result from an inherent limitation in the x86 architecture. And there's a few elements of the x86 architecture that are in limited supply. So let's talk about some files here in the proc directory and what elements of the architecture they're controlling. So we'll talk about DMA, interrupts, and I/O ports. So first let's talk about each of these, then we'll talk about how to recognize conflicts and how to resolve those conflicts. Okay, so DMA, it stands for direct memory access. All right, so these DMA channels exist so that devices can access memory directly without going through the CPU. All right, so if some disk drive and there's some buffer in memory that needs to be written out to the disk drive, then the disk drive can sort of talk directly to memory there to get that information out of memory, and it doesn't have to go through the CPU. So that saves effort on the CPU, so the CPU can go ahead and do other things, and it also speeds up the transfers between memory and the hard drive because the hard drive and the memory are connected via a direct memory access channel. But there's a limited number of these direct memory access channels, and we have to allocate them correctly to all of our different devices. Then there's interrupts, also called IRQs or interrupt requests. And interrupt channels allow a device to send an interrupt to the processor, and the reason the device is sending an interrupt to the processor is because it needs help on the processor's part. Okay, so it needs the processor to do something for it, and so it sends an interrupt to the processor. Again, there's a limited number of these interrupts. Newer PCI devices can actually share interrupt channels, but older devices can't share them. And then there's I/O ports, and I/O ports are used, or also called I/O addresses. These are used by a device to communicate with the rest of the system. So if some device needs to send a signal out, it can write something into this I/O address in memory, and then something else can read that I/O address, and so that's how the device communicates with the rest of the system. So let's take a look at one of these files, and let's look at the interrupt requests assignments in the proc/interrupts file. Down here on the left-hand side, you can see all these numbers, and these numbers relate to the number of the interrupt request channel, and there's the numbers, the interrupt request channels are numbered 0 to 15. Okay, now if there's some numbers missing from this list, that just means those channels are unused and they're available to be used by certain devices. Now, one thing you should be aware of is that there are certain settings of interrupt request channels to certain devices that are pretty standard. Like, for instance, COM1 is typically assigned to IRQ4, and COM2 is assigned to IRQ3. So those are your serial ports. For your parallel ports, LP1 is assigned to IRQ7, and LP2 is typically assigned to IRQ5. Okay, so if you're going to add some device or resolve some conflict that's arising here, and you want to assign a new IRQ to a particular device, keep in mind what the standards are, so that if you do add, like, another parallel port to your system, that's going to be assigned to an IRQ 7 or 5, depending on whether you already had a parallel port or not. Okay, so here you can see over on the right-hand side are the devices that are assigned to the particular IRQ channels, and this one here in particular, number 9, you can see there are two devices there. There's a USB controller, and the ES1371 driver is for my sound card, I think. So those two things are both on the same channel, but they're both newer PCI cards, so that's okay. If you have an older ISA card and you see this kind of a duplication here, that two devices that are both ISA devices, or even if just one of them is an ISA device, and these two devices are both using the same channel, you could run into problems. There could be erratic behavior. It works sometimes, it doesn't work some other times, and it's just unpredictable what's going to happen, but most likely it's not going to work the way you want it. Even with PCI devices, you might notice when two things use the same channel, certain things slow down. And so, if that's a problem, if you notice something's going wrong in your system, this is one of the places to look to see if there's any conflicts of interrupt request channels. Now, on older ISA cards, what you have to do to resolve these conflicts is, on really old ISA cards, there were jumpers that you actually set on the card itself. So there were these little pins, and there were these jumpers. They're basically just like connectors or plugs, they look like, and you just set this plug over particular pins to change what the IRQ number will be for that particular ISA card. For newer ISA cards, you do this via software. So you can set the interrupt request for the card via software instead of actually changing the jumpers. If you do need to change the jumpers on some really old card, you're going to have to find some kind of a manual that explains how to set those jumpers, or you're going to have to sometimes it's printed right on the card itself. So if you don't have directions on the card, or you don't have some manual, then you're going to have to look up how to set the jumpers to change the IRQ. I guess you could just experiment too and switch them around and then see where it comes up in this list, but there is no standard way to set the jumpers, to make the IRQ equal to 6 or something like that. Well, now let's jump over to my SUSE Linux machine, and I'm in the proc directory on this machine as well, and we can see the proc directory is composed of the same sorts of things. This is true for all versions of Linux. And again, I just want to show you the interrupts file on this particular machine, and it's a little bit different than on my Red Hat machine. In particular, interrupt request 9 is shared by the USB controller and a SCSI controller, whereas the sound card is on interrupt number 5. Okay, so slight differences will occur from one version of Linux to another, or from one configuration to another, but basically the same kinds of things apply. Now, like we said, if you have an old ISA card and you need to resolve some interrupt conflict on your card, then set the jumpers on that particular card. If it's an ISA, what's called like a plug-and-play device, then you can set the interrupts and the DMA channels and the I/O addresses via software. And the first thing that you need to do is you need to create a configuration file in the etc directory. Okay, oops, if I could type here, etc, and let's call it isapnp.conf. Okay, so you run this command called pnp dump and you create this configuration file. Now what's being created here for you is sort of like a virgin configuration file. It gives you all this information in there, okay, but nothing is actually set yet for you. And then you need to go through and look at this configuration file, and then basically just uncomment out what you want to set it as. So if we go down here, you can see the first card that's been recognized is this Creative Sound Blaster card. So we're talking about my sound card. You can see the hash marks down the left-hand side, meaning everything is commented out. And then basically you get to this section that says multiple choice time, choose one only. So when you, the way that you want to change this is whatever settings you want to make for your particular card via the DMA channels or the I/O addresses or whatever, you just uncomment out one of these things. And then when you get down here to the bottom of this section, whichever one you want to choose, then what you have to do is you have to activate the card by uncommenting out the hash mark in front of act Y. This activates the settings that you've made up above. Okay, if you need more specific information for a particular card and what settings you should make for some particular card, check out on the internet, do a search for PNP dump, and in the Google Linux tool, and you'll find how-tos on how to configure, for a particular kind of a modem or a particular kind of a sound card, that sort of thing. Well, I just want to talk about the configuration of a couple more elements of the Linux system. First, let's talk about sound cards. On my SUSE Linux system, the sound cards can be configured through the YAST interface, which stands for Yet Another System Tool. And the YAST interface will give you the ability, if you go to hardware and then you go down here, there's the sound element. And so this will allow you to configure aspects of your sound card, for instance. Okay, so you can see here it says the Sound Blaster card is running. If you wanted to add a new sound card or make some options, change some options to this particular sound card, you can do so through this interface. One of the nice things with YAST is if you're going through here, for instance, if I want to set the IRQ number, it's saying here the possible value is 5. If I go to this menu, it'll tell me what IRQs I am allowed to use for this particular card. So it's doing some of the work for you, so that you don't have to go in and make guesses about which IRQ number you should use for which particular cards. Since this is all set up and working correctly now, I'm just going to exit out of this configuration, but that's how you use the SUSE utilities to configure your sound card. In other distributions of Linux, there's similar tools. There's either command line tools or graphical tools like this one that will probe the sound card, try to determine what it is, and with any kind of even remotely modern sound card, you should have no problems getting that to work in Linux. Now, another thing that you can configure through the YAST interface is your modem, and the modem configuration has to do with, what number is it going to dial, what kinds of settings are you using on the modem, and that sort of thing. And again, YAST is a graphical tool that allows you to configure that for SUSE Linux. Other versions of Linux have their own tools for configuring modems. Check out the documentation for your system as to which one how to use your particular software. What the YAS system does is it goes through, looks at your modem, and notice it's saying nothing is configured. I'm not actually using the modem. I have an Ethernet card in my SUSE machine that I'm connecting up to a DSL line. But if you want to configure this, you can go through and configure this, set the dial modes, things like that. On the next setting, what you can do is you can actually pick your ISP. So if your ISP is in this list here, you can go through and pick it. For instance, ZephyrNet, there's the telephone number, there's the internet address for ZephyrNet. You can go ahead next and configure some other things like your username and password. If your thing was not in this list, then you can go to custom providers, go to new, and then you just have to fill in all that information like the provider's name and phone number, and then also the username and password that you're going to use for that particular provider. Okay, so the settings that you can make in here will work for modems for Linux. Be aware that if you're buying a new modem for your Linux machine, to steer clear of Win modems, because Win modems are specifically for Windows, and while there are drivers out there that make Win modems work on a Linux system, that's probably not the way to go. Okay, some of the companies out there are actually developing Linux drivers for their Win modems, but as the name should tell you, they were specifically made for Windows, and they require operating system support on behalf of Windows to make them work, and so they're not recommended on the Linux system. All right, well, it's time to wrap up our nugget on configuration. We started by talking about BIOS settings. And remember, the way that you get into the BIOS is as your system's booting up, you need to press one of the special function keys. In my particular case, it's F2, and that'll get you into the BIOS settings where you can change things like the boot order and things like that. Then we moved on and talked about the proc directory. And remember, the proc directory is not actually a directory. It's not taking up space on your hard drive. It's really just peering in to the kernel, and you're seeing the heart of the kernel and what the current settings are that are in the system. You can see information about all the different processes. And remember, there's 3 files in there, the DMA, the interrupts, and the IO ports file, that control these aspects of the x86 architecture that are in limited supply, okay? And it's telling you how these elements that are in limited supply are being assigned right now. And so if you're running into problems with any sort of device, you can go here and see if there's any kinds of conflicts, either for interrupts, DMA, or IO addresses. We talked about the PNP dump command, which allowed you to create a configuration file that would allow you to change elements of ISA plug-and-play cards. Okay. Once you get done changing the configuration file that was created with the PNP dump command, then you either need to reboot your system, or you can just run ISA PNP with the current configuration file after you've finished editing it, and then the system will recognize the new settings that you've made for your particular device. And then finally, we just talked about some graphical tools in the SUSE Linux system that allow you to configure your sound card and your modem. And most versions of Linux out there today have some sort of tool to allow you to configure these elements. And so you should just see what those tools are for your particular system. But basically, they work the same as what we saw in the SUSE system. Well, I hope you found this nugget informative, and thanks for watching.